Remember this one from Friday? We had two functions similar to the beam, but this was the average, the workers, and accidents. And we said that. So just review. So what makes sense in this problem? F of g of x or g of f of x? Confirm. Talk to the person next to you. What makes sense? F of g or g of f? What would make sense? Go. One of those makes sense, the other does not. Okay, Christian, you're up. What makes sense? F of g of x or g of f of x? Why? So talk to me about the output of g. What's the output of g? No, what does it mean? What's the quantity, the output of g? What the output of g, what quantity does that represent? What do you get when you put something into g? It gives you what kind of thing? What's that? No. Right, it's the average length of a worker shift, right? So in order for this to work, what has to be true? That output of g has to be the same as the input of f. And is it? Yeah, because the input of f is always also average length of worker shift. So they match. So this is okay. All right, so what we were doing last time, we said, okay, so if you got 80 workers, you get a shift length of 10, and then a shift length of 10 in function f results in, we estimate 8 accidents a year, okay? And that was that process we did for several examples. So could we have a one-step process that did this whole thing all at once? And if we did, what would the input be? What quantity would be the input? We want to do this whole two-step process, but streamline it. So, yeah. Right. But that still is representing a two-step process, putting 80 into G, and then taking the output and putting it into F. No, but that's not the original input. So what we're saying is this represents a two-step process. If we made it into a one-step process, what would the initial input be? Would it be average length, number of expected accidents, or number of workers? Number of workers. And what would the output be? Number of accidents, right? We want to take out the middleman. Okay? So we could build a table to do that. We said the input would be number of workers employed. And the output? Expected accidents. Okay, so this would be like a streamlined version of this two-step process. It eliminates the middleman. And you could all build this table, right? You could all do it. You should be able to, from the values in the other two tables. So let's see if it's right. Does 80, how many expected accidents? 8, you see? So this is a new function h that just does it in one step. Okay? Both are considered composition. This side, using two tables, makes it a two-step process. This then streamlines the process and just makes it one process. but the input, the original in and the final out are the same. Okay? So over there you got composition as a two-step process. Over here you have it as a one-step. Both are considered the composition of functions. Both are considered the composition of functions. Okay, so now I want you to flip to page. Flip back one page. And we're going to look at number 2. So this is talking about two functions. It's talking about a situation. You drop a pebble in the lake. As soon as the pebble hits, ripples start to form and travel outward from the center. Okay? So the ripple is traveling outward at 0.7 meters per second. And our goal in the end is to determine the area inside the ripple given a number of seconds elapsed. Okay? So you've got 3 different quantities going on here. You've got time elapsed since the pebble hit. You've got the radius of the ripple, and you've got the area of the circle formed by the ripple. Okay? So I want you to skip to part D on the top of page 93, and it's telling you to define two functions there, f and g. So you're going to work on D, numbers 1 and 2. Go. So, how do you want to distribute the papers?
I was thinking just at the end of class, just make an announcement. I'll have them up there.
After I stop? Okay, it's going to take a while, but I can help you. It's okay. So I need to announce. Okay.
I figure otherwise they'll just be going through them while you're teaching.
Yeah, thank you. It's a good call. If you're having trouble writing the rule for the f function, here's what I suggest. Make a table of values of time and corresponding radius based on the information given. After you make a few ordered pairs, or 2 or 3, you start to see the pattern and you can come up with the rule. Okay, Yaslin. Where's Yaslin? Where's Yaslin? How'd it go? Did you get the f function? No? So at time equals 0, what's the radius? What's the radius when the pebble first hits? 0. 1 second later, what's the radius? 2 seconds after the pebble hits. So what we need is a rule. So t seconds after, what's the radius? So it's at 0.7 times, right? Okay, so first of all, what's the input into f? Is it radius or time? Radius as a function of time. Input is time. So our rule is something with time in it that gives us what? The radius, right? So it's the formula that acts on time to output or give us the radius. So 0.07 t. Every second, it increases by 0.7. So in 2 seconds, 2.7s. In 4 seconds, 4.7s, right? So it's multiplication. Time times 0.7. Okay, so just to remind you, this whole thing, what I put a black box around, that's called the function definition. Definition is the output notation equals the rule. When it talks about function notation is just this output notation. So we use this to represent different outputs. Okay? So that's what we mean by function notation, and the whole thing is what we mean by the function definition. Function definition. Okay, so next, where is Morgan? Okay, so we got the name of the next function is g. What's the input into this one? R. And so what rule do we have of R that gives area?
Pi r squared.
She said pi r squared. What do you think? That's it. So if you have the radius of the circle, this is the rule that outputs area, right? So that's our area function. So now ask you a question. What makes sense? F of g of t or g of f? Sorry, f of g of r? My fault. We'll just call it x, right? So we'll just generically use x. So f of g of x or g of f of x, which makes sense? Discuss, go. Which makes sense? F of g of x or g of f of x? Okay, Jonathan, Wardwell. What do you think? F of g of x or g of f of x? Why?
Area by a function of time. So the inputs and outputs work out.
Okay, so all right, so you're saying the final output of this is what? Area. Initial input is time. Okay, so that does what we said. Now, when you said it's the only one that makes them work out. Can you be a little more specific?
Well, F gives the radius as an output, G takes the radius as an input. That's the only time they line up.
Well said. Did you hear that? He said F gives a radius as an output, and G takes a radius as an input. And so that makes sense because the output of F, we're trying to make the input of G. So F of G does not work because you're trying to put what? Area in for something that takes time. Doesn't like it. So that's not the function of F to take area. The function of F is to take time. So you're trying to give it area, doesn't like it. All right, so g of f of x. Okay, so to find, g of f of 2. All right, so just ignore that question. I just need some more space. Just ignore this. All right, so G of, so what's our, again, G of, was it R? Pi r squared? And F of T was 0.7 T. So if we wanted to know the area at 2.5 seconds, what would we do? Where is Fernando? You're up. I want to know the area at 2.5 seconds. What do we do first?
You put 2.5 seconds into T for the F of T.
An F, right?
Yes. You get 1.4.
Oh, that was fast. How'd you get that?
Because it was previous. Oh, wait, no. I'm sorry. I was thinking 2.5. So, I don't know. I was thinking of it.
It was 2.4, so it'll be 2.75. No, no. Sorry. What is 0.7 times 2.5? 1.75? Thank you. Keep going. You're doing great.
Then you take the 1.75 and plug it into G of R. That would be pi times 1.75.
Someone crank it out. As soon as you get it, yell it out.
9.62.
Thank you. And what's the units on that? Meters squared. After 2.5 seconds. Okay, was this the two-step version of composition or the one-step version? Two-step version. So what we want to do is we want to come up with a new function, we'll call it h, which is the one-step version. So what will the input into h be? Someone said time. Agree with that? Yes. Originally we put in time. What will the output of h be? Area, right? So we want a one-step version that just streamlines it. We put in the time, it cranks out the area. So here's how we do that. So first of all, we said that that is it G of F or F of G? G of F. So watch. What does F of T equal? It equals that rule, right? So we can just write G of 0.7 T first. So now we have a new input into G. The input into G is 0.7 T. What does the function G tell us to do with the input? First do what to the input? Square it. And then multiply by pi. So we're going to take the input, and we're going to do what first? Square it. And then multiply it by pi. You see what I did? So that tells me if I put something into G, anything I put into G, we're going to square it, and we're going to multiply it by pi. So I took that, I squared it, and I multiplied it by pi. And then I can simplify that, and I get 0.49 pi t squared. Okay? And so this is the rule for our h function. So what I want you to do is I want you to put 2.5, find h of 2.5. H of 2.5, meaning what's the area after 2.5 seconds? Those who did it should find exact same answer, right? 9.62 meters squared. So by taking the rule for F, the rule, and making it the input of G, we can follow the algebra and get a new rule that's the one-step version of composition. It takes time and gives area instead of going through the two steps. Question?
Is it possible to do the one step with R without? It's not possible to do the one step without R. You have to do the two step. Is it?
I'm not following. Say it again.
Like, can I? I'm not calling you on to do the one step, but I think I do have to have the information for the second, the two steps before you do the one step.
Yeah, you need both functions in order to create this.
Okay.
You need both the original functions to create the composition function. Yeah. Really important idea here. Does it make sense? Anybody else have another? Is that a question or a stretch? Okay. All right. So can I erase this? Okay, look on page. Oh, so let's see a visual of it. This is nice. So here is time goes into F, gives radius. Then we put radius into G, and it gives us area. That's what we did first. So time gives radius, radius gives area. Two-step version of composition. And then what did we do? We did some math, and we figured out a single formula that does it all in one step. So it's a different function that has the same process as the two-step function, or the putting the two original functions in succession. Just eliminates the middleman and just gives us area right from time. Okay. So I want you to skip up to this page. Where's this? What page is this? '96. So when you have functions in context, you have to be careful that the output of the first function matches the input of the second, right? We've been hammering that. That you can't have a valid composition unless what's coming out of the one is the same as what you're putting into the next. But if you don't have context, it makes perfect sense to talk about, say, in this case, you have your rule is for f is radical x plus 3, and your rule for g is 2x plus 9. So without knowing what quantities your input and output represent, they're just values, then it's valid to talk about f of g and also g of f. It's totally valid. Okay? So f of g of 2, quickly here is, I'm going to plug 2 into what? G. And I'm going to get what? G of 2 is 13, right? 2 times 2 plus 9, 13. And so then I'm going to do what? 13 into here. And I'm going to get 4, square root of 13 plus 3, which is 4. Okay, so what I want you to do is find a new function, we'll call it q, that does the one-step version of f of g of x. So find a new function q that does that two-step process of first g, then f, does it all in one step. See if you can do it. And then next we're going to do this one down here, which is p is g of f of x. So we're going to do it both ways. Those are the two you're doing. Find the one-step process for q and the one-step process for p. Okay, so that first step, f of g of x, is to put the rule in for g as the input of f. That's what that's saying. Take the output of g, make it the input of f. So the output of g, when the input's x, is 2x plus 9. There's the output. So we can put it in as now as the input of f. So what does f tell us to do to the input? What does it do first? No, f tells us, so this is the instructions for function f. The first thing that f tells us to do with the input is what? Add 3 to it, right? So you're going to take the input, here's the input. The first thing it tells us to do is add 3. You see? And then what's the next thing f tells us to do? Square root of the whole thing. So there we get square root of 2x plus 12. And that's our Q function. So that's the one-step process. That's the same as what we did before here. So if you plug 2 in, what do we get? 2 times 2 is 4, plus 12 is 16, square root is 4. Q of 2 is 4, just like we got before. All right, P of x is doing f first. And so it's g of f of x. That's right here. So what is f? That's the output of f. So what does the rule for g say to do first? What did you do first with the input? Double it. So we're going to double the input first. 2 times square root of x plus 3. And then add 9. And that's our P of x. Can't simplify that. Notice that P of x is totally different than Q of x. Two totally different functions. So if you change the order of the processes, if you change and do the other one first, and take that output and make it the input, you get a totally different result than the original order that you picked. So changing the order of the processes changes the outcome. Okay, questions on this? So this is now using the rules to find a one-step rule that simulates or reproduces the two-step composition. Chance for questions. Okay, flip to page 102. Okay, so here it's talking about converting Celsius to Fahrenheit. We have this function g of c. This function g of c right here that takes the Celsius temperature as input, and the rule then generates the corresponding or the equivalent temperature in degrees Fahrenheit. Okay, so g of 100, just as a quick example to start. 100 represents what? Degrees in Celsius. And so what does this function say to do to the input? Take 9/5 of the input and then add 32. That's what this function says to do. Take the input, multiply by 9/5, add 32. And when you do that, you get 212. And what does that number mean? And what about 212 degrees Fahrenheit? That's the same temperature as 100 degrees Celsius, right? That's the output of G, which is the same temperature as 100 degrees Celsius. Okay? So, given that rule, how can we create, so we've got that G of C is 9/5 C plus 32. Now I want to create another function, h, that's input is f. So now the input is Fahrenheit and gives me the equivalent temperature in Celsius. So how can I find that rule? So if I have this rule here for my function g, f equals 9/5 c plus 32, what do I want now? I want to have something like c equals a rule of f's, or an expression with f's in it. How can I get it? How can I get, what I want is to be able to figure out C equals something with F's in it. How can I do it? Yes, sir.
Solving for C.
Right. So if we isolate C and solve for C, then we'll have an expression that has F's. So what's the first step?
Subtract 32 over.
So F minus 32 equals 9/5 C. Then?
Divide over the 9/5.
Right. So we could divide by 9/5, which is the same as? 5/9 times the quantity, F minus 32. So this formula takes Fahrenheit and gives us the equivalent Celsius. So that's the rule we want for H, right? So how are these two functions related? How are they related? So this one takes Celsius and gives Fahrenheit. This one takes Fahrenheit and gives Celsius. And what's that? So how are they related? What's that? Okay, that's true. That's right, because the output of one is always the input of the other. That's true. Their inputs and outputs are switched. But what about them as processes? How do they compare as processes? What is that, though? So what does that mean? They're inverses of each other. Opposite. Opposite means kind of like multiply by -1.
Put the C into the equivalent F and function.
Okay? Yeah. Yeah, so the one undoes the other. So whatever G does to a Celsius, so for instance, G of 100 gave us 212, right? Now what if I took 212 and put it into function F? What am I going to get? 100, because H undoes or reverses what G did. Okay? That's the meaning of inverse, right? The meaning of an inverse function is a process that reverses the first process or undoes the first process. So therefore, what if I were to compose them together? That's what some of you were talking about. So if I took H of G of C, what would this mean? First take a Celsius temperature and get what? Fahrenheit. And then take that Fahrenheit and put it into H, which will give me? Right. So let's do the mathematics behind, and what do we expect to get when we do that? You'll get the original Celsius. So let's do the math behind that. Hold tight. So, first we're going to do H of what? So what is the rule for G? 9/5 C plus 32. So now we're putting this input in for H. And what will that be? So what does H tell us to do with the input? What does it tell us to do first? Subtract 32 from the input. So you take the input, 9/5 C plus 32, and you do what? Subtract 32. And then what does it tell you to do? Right? So now, what do we get inside the parentheses? We got 5/9 times 9/5 C plus 32 minus 32 equals 9/5 C, which equals C. It worked. So we just proved that H undoes G. Now we want to do that a second time, not now. We want to prove that G undoes H. And when we prove both of those things, then we can conclude that H and G are inverses of one another. Okay, Roy's got your homework. The two of us are going to turn back homework to you. Exam on Thursday. I'm going to post a review outline this afternoon. Elizabeth. Elizabeth. Tanner. Justin P. Piazza. Justin Piazza. Justin Rayner. Morgan. Justin Richardson. Adam. Hey, that's right. Tyler Shackelford. Tyler. Sarah. Lorenzo Smith. Renee. So you won't have any other list. 4 workers or 2? G, what's wrong, G? Gosselin. Malenko. G. Wallace. Wallace. Zach Wilden. Zach Wilden. Edward Williams.